Hello everyone, my name is Rachel Santi and I am an intern with the Center for Western Weather and Water Extremes, Yampa Valley Sustainability Council, and a student at Colorado Mountain College. This summer I was able to work on a project in Steamboat Springs, Colorado involving the beginning stages of a soil moisture monitoring network in the Yampa River Basin. Steamboat Springs is highlighted here in the yellow star. This project was aimed to better conserve and manage water in the midst of a severe westerly drought. The title of my project is a sub-basin comparison of soil moisture to inform meteorological station location. Again, my name is Rachel Santi, and my awesome mentors include Anna Wilson, Madison Muxworthy, Nathan Stewart, Michelle Stewart, and Nicole Pepper. As we talk about research done in the Yampa River Basin, it is important to note where the Yampa River is compared to the larger Colorado River watershed. So Steamboat Springs is again highlighted with this yellow star. We're in the northwestern area of Colorado. The Colorado River and its tributaries are an important source of water in the western United States, supplying water across 7 states and Mexico. This issue is important because the Colorado River no longer reaches the ocean, showing how much water has decreased over time. And as Elisa Senga points out, mountains provide the headwaters for millions of water users. It will be increasingly important to monitor soil moisture in the context of understanding water availability and improving water forecasts for utility managers. While reading key literature related to soil moisture in a snow-dominated watershed, I came across a significant quote explaining soil relating to our drying water conditions. Again, water in the West is becoming a huge concern to society. When the soil in a watershed is dry, water absorption by the soil can significantly reduce the amount of precipitation making its way into streams and rivers. To the left, we have very dry soil where vegetation is kind of struggling. And to the right is a very saturated wet environment where the vegetation is thriving. And now I'll explain key literature relating to the importance of soil moisture relating to vegetation and water pathways. The sustainability of water as a resource is directly influenced by the soil through plant utilization, flow path, and quantity, showing a key physical function of soil moisture. As you can see in the left picture, water evaporates directly through the soil and plants. Warmer conditions are eroding the flows of tributary streams as vegetation draws more water and as more moisture evaporates off the landscape. So in other words, warmer conditions are causing water to be lost in the atmosphere rather than staying in the soils. As temperature increases, plants uptake more water through evapotranspiration, which is defined as water transferred from the land to the atmosphere by plants and soils, leaving less water in the soil and groundwater table. And I also want to note that soil moisture data is used now to forecast droughts. So that's kind of an underlying reason why we want it in our valley. The motivation behind this research was to explore how sub-basin variability in soil moisture could potentially influence where soil moisture monitoring stations are sited in catchments to best support water management decisions. This is aimed to better understand the effects of climate change. My research question is as follows. How do in situ soil moisture measurements vary at the sub-basin scale, and what landscape level parameters potentially influence that variability? My hypothesis is in situ soil moisture measurements would be greater in water catchment zones than upslope areas. To answer this question, I used Google Earth, USGS, both to identify water producing zones, also known as catchments, and existing instrumentation to influence my site selection. I used a TDR 150 soil moisture meter that is also used by our local Forest Service partners to measure volumetric water content, a percentage volume of water to the unit volume of soil. I used time domain reflectometry to measure soil water content based on the travel time of high frequency electromagnetic pulse through the soil. My transect sampling, I used a tape measure for linear site measurements at 10 feet intervals until 150 feet. I used a shovel to take soil samples just to take notes of the soil, and a digital compass to take a transect bearing, and an inclinometer to measure slope angle. And to the right, I forgot to mention that that is the TDR 150 soil moisture meter. I apologize. Oh, there we go. Sure. Here is a map of the Upper Yampa River Basin, which is outlined in gray. Circled in red is my first site location, the Buffalo Pass Wilderness, where I took 3 soil moisture transects in between snowtail sites labeled A and B. Circled in purple is my second site location in the Flat Tops Wilderness, where I took 3 soil moisture transects near snowtail sites labeled C. The blue dot on this map represents snowtail sites. Both locations supply an immense amount of water, contributing to Both locations supply an immense amount of snowpack each year, contributing to streams and rivers that influence our water supply. The Buffalo Pass Tower Snowtail site maximum snow depth was 140 inches in 2020. I chose to locate near snowtail sites because they measure precipitation, temperature, snow depth, and sometimes wind speed data. This and stream gauges include information that water managers are currently using, and I want to note the variability of soil moisture and water and soil interactions. Along with existing snowtail sites, my site selection included locating catchment areas based on field observations were mostly what I used to locate these sites. Catchments are seen as the most effective management unit for protection of water resources, both water quality and supply. Catchments are where water collects and spills into a single water body. Google Earth helped me identify these along with field observations. Here to the right is Google Earth, just kind of showing that there's water collection areas and it spills into that stream. I used plant community indicators, willows, ferns, corn lilies, and aspen trees. I also used physical catchment indicators and thermal streams, where water only flows shortly after precipitation events, streams and rivers. And then I used topography, just kind of observing an area bounded by hills, creating a bowl-shaped area. Here is a map of my transect line, starting at the catchment area, going upslope, with vegetation changing throughout my line. Pictured below is an example of each site or each sample I took, soil moisture touching the ground, reading volumetric water content at 4.8 inches and 8 inches into the ground. Here are some field pictures from my field work, just showing that this area is creating a bowl in the landscape where I started my transect, just because I wanted to show that that's a key water producing zone. And then I measured transects going, or soil moisture transects going uphill. And then down here is a picture of soil samples I took at each site, just to kind of take notes of how dry or wet the soil was. These next 2 slides are the same comparison of in situ observations of volumetric water content along the y-axis and distance of going upslope away from the catchment along the x-axis. In blue, we have volumetric water content at 4.8 and in red, 8 inches. The start of the transect line is here highlighted in orange in the catchment where volumetric water content is very high. And as we move away from that catchment zone, the volumetric water content decreases as we go into the grasses and shrubland, and then again spikes up in the tree canopy. The tree canopy is kind of defined as an overhead shade source, so these aspen trees over here. Results are showing there is a notable relationship between vegetation and water availability that would be very beneficial for water managers to use in our valley. Again, here we have a similar graph, just different area. Starting at the catchment zone once again, going away from the catchment zone in the grasses and shrubland. Volumetric water content once again decreases as we entered the shaded tree canopy. Volumetric water content increases again. And I want to note that the jump in volumetric water content circled in blue is about the same volumetric water content as the start of the transect line near the catchment zone where water often collects. Kind of just showing that the vegetation exposed is evapotranspiring at a much faster rate, losing water at a faster rate. I want to bring your attention to soil moisture and precipitation. Precipitation falls from the sky and interacts with the soil, where water is often stored or lost. Listed to the left is average volumetric water content from these sites at 2 different depths. To the right is precipitation I obtained from the NRCS website. In red, Buffalo Pass, in blue, Flat Tops. The stars indicate the days I was at each site. The data shows an opposite correlation between volumetric water content in the soil and precipitation measured in the precipitation gauges in the snow-tail sites, showing there is a large gap between soil moisture and other useful data that is missing the soil-water relationship. Some conclusions from my research: in situ soil moisture measurements vary across the sub-basin. In situ soil moisture measurement variability is influenced by landscape level parameters such as vegetation cover, soil type, slope, aspect, and elevation. Advice for future soil moisture placements: focus on catchments if the goal is to understand water pathways. Potential future studies: quantify the impact of evaporative loss at the sub-basin scale. I just want to acknowledge my awesome mentor team. Thank you, Anna Wilson, Nathan Stewart, Michelle Stewart, and Madison Muxworthy. Cody Paulson, you were an awesome intern leader. Ryan Adams, soil scientist, Medicine Bowl Route, National Forest. He worked with us on a field day. It was awesome. And then I want to thank Elisa Sanga, Rachel Jones, and Julie Vano. You were an awesome Colorado cohort this summer. Here are my references. And I'm now open for questions. Thanks for listening. And I'm looking forward to seeing the rest of the presentations.